Hello students, let us look at the second part of robot application in industries. Next is in assembling. In assembling is when we have in industry a process wherein an equipment is one by one assembled by attaching various parts to it. Okay, and it is programmable and it has to be done at a certain speed, at a certain accuracy. Now, what we have written here is mostly it is taken from a little bit older version of the books. So today many of things are much advanced than what is written. But anyway, the assembly system is mostly programmable and hence it is very cost effective, because if we are having a line of robots, a line of robotic arms that are operating on anything that is there on the assembly line, and one by one it is moving forward, we can complete the batches very quickly. Okay, now for doing the work more properly, we may have tactile means touch based, or optical sensors. So you may have something to touch and find out things, or you may have cameras installed so that the robot is basically able to handle very complex tasks. Now there can be one single robot doing, or one single robotic arm doing the whole work, or to reduce the time we may have multiple robotic arms doing the work. For example, in yesterday's video I had shown you the robotic system of Audi factory floor, wherein you might have seen that multiple robots are operating on the body of the car to finish it quickly. Okay, so there might be some assembly tasks which require even more than one robot. Okay, and to reduce the cost per arm means to reduce the cost per robotic arm, there are systems in which several Cartesian arms can be used with the same base and share the same controller. So it's something like this: you will have one base which is controlled by a single controller or a single computer, and there are multiple robotic arms on it. So one or two or three robotic arms are there, and what they have written is Cartesian arms. Cartesian arms is a kind of robotic arm that you will see in future. Anyway, so assembly robots basically can be designed in any coordinate system, whether it is spherical coordinate system, Cartesian coordinate system, or cylindrical coordinate system. I understand that you will not understand the coordinate systems now. It is basically the different type of robotic arms that we are having. We can have cylindrical, we can have spherical, we can have Cartesian, or even articulated robotic arm. The types of robotic arm, when you will come to higher modules, you will be taught. Okay, but the most effective one is a SCARA type model. In yesterday's robot video that I had given, there is a robot for the SCARA type. Okay, and SCARA type robot is mostly used for tabletop applications, wherein you are having this mostly assembling kind of job. And SCARA robots are produced or developed in Japan, and the name is basically Selective Compliance Assembly Robot Arm. So most of the complex tasks can be very well handled by a SCARA type of robot. I will be putting videos of each type of robot and you will get to understand it much better. So even though you might not be clear at this time, once we have finished all the portions and you know all the different kinds of robot, once you read back these portions, you will be in a very good position to understand it. Okay, the next is machining. What is machining? Machining is when we have to operate on metals or any material to produce a kind of end machine that we desire. Now there are many operations, machining operations. Some of them are like drilling, lathe machine or turning machine. Lathe machine, you might have seen, there is a big machine in which you connect something and it keeps on rotating, and as you rotate it, the object you are able to machine. So that is basically called as a lathe machine. Okay. And then there is milling machine. Milling machine is basically when you have a kind of machine in which material is slowly taken out from the surface. Okay. For example, there is this kind of a block, and you want to take out the top 1 millimeter thick material if you want to take out. Okay. Or if you are having a cylindrical piece like this and you want to take out very small thin sheet out of it, then you use what is called as a milling operation. So it's basically it basically smooths the surface. Okay, milling operation. Then we are having shaper. A shaper is a machine that gives shape to any metal. Okay. And then there is grinder. Now all of these machining that are done are basically with the help of machine tools, and nowadays all of these are done. Okay, nowadays we are having all of this being done, and since I have taken this from a very old book, right now all of these are done, but that time it was written that only drilling is mainly used. Okay, but right now most of the industries are using most of these machining operations. So I will ask you not to consider this statement. Okay. Another big thing is deburring. Okay. Now deburring is something very important in those days, not now, because previously the metal parts were cut using metal, cutting machines and all. But today they are cut using lasers, and you don't require a deburring machines. Now what is deburring? Deburring is, suppose you have cut a metal according to a shape that you require. Suppose I have cut something like this. Now the ends of this will be very sharp, and it may have small shards of metal, or there might be very rough edges might be there, and this is not good when metal is being handled. So you want to smooth that out. You want to smooth those edges out and these corners out, so that it is not it looks very as a very finished product, and that process is basically called as deburring, because what I told about these rough edges and these parts that are hanging loose, they are basically called as burrs. Okay. So deburring is one of the big machining works that can be done by in the category of machining. But as I said, the main things are drilling machines. It's used in lathe or in turning machines, milling machine, shaper, grinder, everywhere it is used. Now let us come to some of the state of the art applications of robots. That means state of the art means very latest. Okay. Some of the fields which are there, which is very much used, the robots are used very much. One of it is medical field. Now see, for the notes purpose I have written maybe a paragraph, 2 paragraph, 3 paragraphs, but these are things that you can keep on reading more and more. I will give you assignments such that you explore a little bit and you find out more about these kind of robots, because if at all they are asked in university, if you are having more and more material to write, that will be good. Okay, let us start with the medical application of robots. Okay, medical application of robot is basically that we are having a robot to help or assist the surgeon. It should not be considered that robot will do all the operation. No, a robot can never be a surgeon. I'm not saying never be a surgeon, because again that will be a very I cannot be very sure of that, because maybe someday a surgeon may be replaced totally by a robot, medical robot, but as of now it is not considered to replace a surgeon. then why is he there? Why is it there? Why is the robot there? The robot there is basically to cooperate with the surgeon, help him. Okay, that's why it is written here, the goal of surgical robots is not to replace the surgeon with a robot, but to provide the surgeon with a new set of very versatile tools that extend his or her ability to treat the patient. So it's just basically used for helping or assisting the surgeon. Okay, that's why they are called as mostly as surgical assistants or cooperate with the surgeons. Okay, now there is something called as remote surgery, but that is for not very, what do you say, it's not for very difficult surgeries, it's for very simple surgeries. Okay, now which are the two kinds of robotic assistants that are there? One is called as the surgeon extender, and the other one is called as the auxiliary surgical support. What is the difference between these two? You should understand. See, an extender, a surgeon extender is, you have a surgeon, and the surgeon is basically having arms, and he is basically doing surgery with his arms. But there might be many things that is not there in his control. For example, he might not be very dexterous. Dexterous means he might be not very much skilled with his equipments or with his tools. His hands might have a small shake. So what a surgeon extender does is, it basically offers the option of a kind of controller in front of the doctor, so that from the controller the robotic arm will go and do the surgery, and it is basically being controlled by the surgeon himself. Okay, so the surgeon will basically have not his hands inside the patient, but basically the robotic arm will be inside the patient, and there will be a camera also there, so that the camera will capture the feed and will show in front of the doctor what exactly where the two arms are, and the doctor will be, with the help of a joystick, the doctor will be able to move and do any surgical aspects that has to be done, whether it is stitching or not. See, what happens is, when a surgeon is doing a surgery, he has to look at the inside of the patient and make very minute decisions. At the same time, his vision is restricted by how much blood is there. So you might have seen that there are nurses standing besides the surgeon who keep on clearing the blood. If there is any blood, they keep on clearing the blood, because they have to very clearly see and then do the surgery. Okay, so all these issues can be solved if you are having a robotic arm placed in front of a surgeon, and the surgeon is basically accessing the joystick of the robotic arm and doing the surgery. If suppose the hands of the surgeon are shaking, the same shake won't come in the robotic arm. Okay, that's why it is written, it is a robot controlled directly by the surgeon. Okay, so it's a robot which is directly controlled by the surgeon, and they augment means they help, or supplement. Okay, augment or supplement means they help by adding. Okay, the surgeon's ability to manipulate surgical instruments during surgery. For example, a doctor has to stitch with his hands. It will be a little bit tiresome and long process, whereas if he is able to correctly give instructions to the robot will do the stitching within very short duration of time. So it will basically improve, or it will help the surgeon's ability. Okay, the promise of these systems is that they can give an average surgeon superhuman capabilities. Okay, such as elimination of hand tremor, that means the shaking of hands, or the ability to perform dexterous operation. What is the meaning of the word dexterous? Dexterous means very skillful. Okay, to perform skillful operations, dexterous operations inside the patient's body. Okay, as a result of all of this, the casualty rates are reduced and the length of or the duration of operation gets short. Clear? And then there is something called as the auxiliary surgical support. In this case, the doctor is there to do the surgery, so his hands will be inside the body of the patient. Okay, his hands will be inside the body of the patient while doing the surgery, and he will be assisted by robot. So that is auxiliary surgical support. Okay, so it generally works side by side with the surgeon and perform such functions as endoscope holding or retraction. That means, see, when the doctor is trying to do an operation, there are many things that a doctor needs help with. That's why you have nurses standing besides the doctor, basically helping him. So these can be replaced by these auxiliary surgical supports. Okay, what is an endoscope? Endoscope is a small camera fitted in the end of a tube to see the inside of human body. Okay, that is an endoscope. Okay, these systems typically provide one or more direct control interfaces such as joysticks, head trackers, voice control. So these are all used to control that robot. However, the surgeon should be attentive during their use. Unlike in the previous case, because the previous case the robot is doing, but here the doctor has to be very careful because he is doing his he is working on the patient, and he should not give a wrong command to the auxiliary robot. Example, while using robot vision to keep the endoscope aimed at the anatomic target. Okay, so if he wants to see a particular vein, or if he wants to see a particular artery, the endoscope should be correctly pointed. He should be very careful that it is not pointed away and all. So you have auxiliary surgical support where the robot basically stands mainly like a nurse, whereas the first one, which is surgeon extender, is basically the robot is doing the operation, but obviously controlled by the doctor. Okay, now surgical robots must be compatible with the operating theater. That means it should it should be completely covered. If you go to videos which show surgical robots, you will see that it has special kind of covers that are there. Then compatible means that it should follow every rule that a general operation theater requires. So if you want to replace parts, it should be replaced after one operation straight away, because in health generally when you use something for surgery, you do not use it again unless it is sterilized. So all those things, okay, all those things should be taken care. It should not be very noisy. Okay, it should not be leaking and all those things. The robot must have sufficient strength, good accuracy, dexterity means skillful. Okay, meaning skillful. Dexterity for its intended use. It must be placed where it can work on the patient while also allowing access by the clinical staff. That means it should be placed either on a operating table or somewhere besides the doctor, where everyone can access it. Okay, so these are just simple things to take care. Next is mining. We know mining is basically when you dig the earth, go inside the earth and try to bring out minerals such as gold, silver, coal, or other iron ore, all those things. So what is the problem with mining? The problem with mining is that the environment, it is very inhospitable. That means it is unwelcoming to the humans. Inhospitable environment which has lots of dust, noise, gas. Gas is very dangerous, especially in coal mines. In coal mines, one of the biggest casualties because of gas leakage. Because if you take a mountain and people are digging inside it, there might be pockets wherein for millions of years methane gas may be there, and methane gas is odorless. That means it does not have any smell. So people will not get an idea, and they will go and just, somewhere they will puncture that particular cavity, and the gas will start leaking inside the chamber, and everyone will be poisoned. People will not realize, and very suddenly they will start dropping on the floor. And gas accidents happen very very often in mines. That's why people always take a lot of detectors to see if there is gas leakage. Okay. And then there is a lot of water. Why? Because again, just like gas, there are also cavities which contain water, and there is always a lot of leakage inside the mines. So all these are very inhospitable conditions for humans to work with. Okay, so there robots can do a lot of work, because robots can replace humans, isn't it? In coal mines, room and pillar mining is accomplished by repetition of well-defined cycle of cutting coal, removing coal, and supporting the roof. So it's like, you are having, you have to build a tunnel to dig out coal. Then basically the robot will keep on digging and bringing out the material one by one. It will keep on digging, and slowly the tunnel will move forward after taking out all the coal. So these things can be done by robots. So the robot is not much affected by gas or noise or dust or anything. Okay. When a robot is used, the ability to maneuver it is easily constrained. It in highly constrained corridors like corridor like environments, and to accurately cutting coal is required. Okay, that means you require high accuracy for cutting and for maneuvering. What is the meaning of maneuvering? Maneuvering means to move around. Okay, that means if you have a big robot, the robot must be able to be maneuvered. That means it should be able to be moved. Okay, because the rooms or the tunnels which you dig for coal mining are very very small. Okay, the corridor is very very small. Similarly, data from laser range scanner can be used to model the environment and to compute the position of the robot. That means if suppose you are having a room, okay, where you have done some what do you say, excavation. Now you want a robot to move inside and do its work and take out more coal. So there they first what they do is they send a scanner inside, and the scanner completely scans the room. Okay, it completely scans the room, and it gives this picture to the controller or to the computer. The computer then tracks things that, okay, I will cut this much of portion today. So it will mark this much of portion, and the robot will move inside and try to basically take out this much area. So one by one it will slowly carve out this much area. So that is what is meant by that. To accurately data from laser range scanner can be used to model the environment and to compute the position of the robot. So exactly where the robot is right now you can understand, and then you can do the mining activities. So that is where robot is highly used in mining, because it can totally avoid the humans to be present in such inhospitable environments. Next is space applications. Nowadays, a lot of applications of robotics are there in space. Okay, what are they like? For example, space manipulation. That means, suppose if you are having a satellite on the in the orbit, and there is something that has to be done. Generally, right now, what they have is they have a small spacecraft with robotic hands attached to it. Okay, just like a robotic arm. And these robotic arms are used to basically work on the damaged area, or wherever the servicing is required. Previously what had to be done was that a astronaut or a cosmonaut had to put a suit, okay, had to put a suit and do what we call as spacewalk, and go outside, do the servicing and come back. Now there is no need to do that. The person can sit inside, and with the help of robotic arm it can do the work. Next is surface mobility. Surface mobility is basically for planetary exploration. For example, we are having rovers. So we are having Mars rover, we are having lunar rover. Even India planned to send one rover, but unfortunately it could not achieve its mission and it crash landed. Otherwise, there was a small rover inside the lunar mission to take samples of the lunar surface. Okay. Another is robotic colonies. That means before humans go to Mars, most probably what will go there is robot, and robots will form colonies. Okay, and they will do farming there until and unless they build a hospitable environment for humans to come and stay inside. It will be first the robots that will go. So robotic colonies are basically meant with that idea. Okay. In addition, the robots may perform scientific experiments that include, sampling and returning of the planetary atmosphere or terrain. That means of soil sample, of surface sample. Okay. Or manipulating the environment, like moving the rock, drilling. Okay. So for all these scientific equipment handling and all, it's mostly going to be done, or it's basically done by the robot. Okay. Then when we are talking about space robots, what are the characteristics that a robot should have for space missions? One is that it should be very compact and light. Why compact and light? Because we know that to send a rocket with some material onto the space is really costly. It's really costly. Per kilogram it comes in millions or billions. So to send that payload is carried by a robot only in this much area. Okay, that is where SpaceX, you all might have heard about SpaceX, isn't it? So SpaceX basically is a private company. Elon Musk operates it, and they basically want to develop rockets which are able to send heavy payloads, very heavy items they are able to send to space. That's why you might have heard of the Falcon series having the Falcon Heavy. Okay, Falcon Heavy can carry a very heavy load. Okay, so Falcon Heavy is one example of sending very heavy equipment to space. So in future we will find SpaceX sending these kind of robots. But anyway, when the robots are being designed, then we will have to look for the compactness and making it as light as possible. Compactness means that it is put in a very small space. That means it comes in a very small space. Okay, so compactness and lightness is something that has to be there for robots which go for space mission. Another is robustness. Robustness means there should be very less chance of error to occur in that robot. Okay, otherwise what will happen? You send a robot up there and then you understand that, oh, it has malfunctioned, it is not working properly. So all the effort that you have put, the amount of money you have spent behind for doing that exploration work is totally wasted. So whenever we talk of a robot being used for space mission, it has to be a very robust one. Okay, but to obviously make it a robust one, the cost goes very high. Next is versatility and adaptability. Versatility and adaptability, one of the best examples that I will give is, just look at the shape of the tires and the legs that are holding those tires in the case of rovers. You just go to any of the images and you look at how the tires are, why they are designed like that is basically because we don't know what is going to be the environment and what is going to be the next challenge that the rover is going to be given with. So you want to design a rover, which is able to run anywhere in any kind of terrain. It should be able to move. So in such a case, you have to take care that the robot is highly versatile and it is very, very adaptable. Okay, so these are the three main characteristics that should be taken care of a robot which is going for space missions. Next is underwater. Underwater applications. Nowadays, actually, the applications are increasing every year. Okay, even my work is right now in underwater. What do you say? Communication. It's basically for connecting the robots with each other when they are working when they are working together for any job. For example, underwater mining is there. Okay, underwater mining is there. Sometimes we have to go underwater and try to take materials that have sunk with a ship, or we may want to bring up a ship totally so that we are able to use that ship again. Not very old ship, any recently sunk ship, it can be slowly brought up. So for that, robotics is being used. Or you want to service a ship. For example, if you have a ship kept on sea for very long time, barnacles will attach under it. Barnacles are just like you are having seashells. They get themselves attached under the ship, and the speed of the ship goes down. So for clearing, and basically it decays the ship. So for taking care of the ship, for servicing the ship underwater and above the water line, we can use robots. Okay, so let us read it. So underwater application of robots involve prospecting for minerals, that is basically a kind of mining on the floor of the ocean, or salvaging, that means saving sunken vessels, that means sunken ships, and the repair of ships either at sea or in dry dock. Okay, because at sea, if you are able to do the repair work, it is very good, otherwise it's very costly to take it in dry dock. Okay. In the later case, a prototype version of a mobile robot that is used to clean barnacles from the sides of the ships. Okay, now this is very, very common nowadays. Okay, so basically it grips the surface of the ship with the help of vacuum and magnetic field. Okay, and then it basically does the scrubbing so that it removes any barnacles that are attached to it. So underwater exploration also requires the robotic help. The last area is the defense area, and now defense area is seeing a lot of robotic application, mainly being the drones. Okay, mainly being the drones. And in very distant future, we will have countries deploying only robots to fight and not humans, and robots will keep on fighting, and there will come a stage when robot will fight against robot. It will be just like video game. We will have 5 drones following another set of 5 drones, or they will be attacking another set of 5 drones. So like that, tomorrow's defense technology will mostly rely on robotics. Right now there are robotic experiments that are being done outside to help soldiers carry their load, or even trying to give extra limb to the soldier so that he can carry very heavy things. Previously, when heavy equipment had to be taken in battlefield, horses were being used, but then later it was replaced with tanks. But even tanks can't go everywhere. There are some places where it is very difficult to go for even tanks. In those places, a robotic, limb robot, that means a robot with legs. A robot with legs can basically take all the load that is put on it and carry it with the soldiers. Okay, so like that, there are many applications that are happening. Another is for guard duty and sentry duty. Okay, another is for guard duty and sentry duty. That means, suppose you are having big oil fields, or if you are having big military installation areas, or nuclear power plants where you want to constantly be on the lookout for terrorists or enemy. That is done with the help of small, drones that fly around and take images and send it back to the receiver, so that the receiver can basically have an eye everywhere. So a lot of things are going to happen in defense in the field of robotics. So these are all the applications, industrial level applications that we have seen. Okay, let me again, yeah, we had started from here. So industrial level applications was there in material handling. Then we have seen in spray painting, in welding. Okay, and then we have seen it in machining, in assembling. Okay, and then in state of the art applications in medical field, in mining, in underwater exploration, space exploration, and finally in defense. Now what I plan to do is I will keep on giving small articles for you to read, so that you are able to collect more information, because questions in this section mostly comes in essay form, and you should be able to write more and more points, so that you get good marks in it. Okay, so this will finish our first module of the basics of robotics, which basically dealt with introduction to robotics and the application of robotics. Okay, next class onwards we will start with the second module. Thank you.